equations from word description. So we're going to have a little word description. We're going to write an equation that matches it. Okay? So I've kind of broke it down into 4 steps here. So step 1, identify the initial value, cost, or starting point. Okay? Step 2, identify your rate of change. Step 3, identify your meaning of the variables. And then step 4, which I forgot to put in there, is put it all together. So let's do this one here. It says you save $15 a week, and you put it into your bank account. You start with $200 in your bank account. Okay, so my initial value or cost here, I'll do this one in blue, is the $200. That's the initial amount I have in my bank account. So I'm looking here, I have 200. Then, if I do step 2 here in gold, your rate of change, I'm looking for words like per, a week. This one says so it's $15 up. So it's $15 per week. Okay? So my meaning here are the variables I use. If I put it together, I'm going to put W for weeks. Okay, and then I'll do maybe S for savings. Okay. And my equation, if I was calculating my savings would equal, well, $200 plus $15 per week. That'd be my equation to kind of go along with this. So my starting point was 200, and I'm adding $15 per week. So it's $200 plus 15 per week. Okay. We're going to come back to the graph. Should we come back to the graph, or let's do the graph now? Let's come back to the graph. Okay. So here's another word question here. A plane takes off and rises at 10 meters per second. So my initial part here is taking off. So that means my initial is going to be 0 since I'm on the ground. Okay. Then my rate of change, here's my per, so I'm looking for something that changes. 10 meters per second. So 10 meters per second is my change. Okay, I'm kind of looking for the height of the plane if I was calculating this. So first of all, I'm going to go, where's my pen here? S is going to equal seconds. So I'm going to switch it here. Like the pink, it's easy to see. Then here it's going to be my height. So what am I calculating? I'm calculating my height. So my height is going to equal, well, I don't have any initial, but I know I'm going up 10 meters per second. So H equals 10S as we go here, okay? We're going to come back to the graph. Let's go a couple more here. And we're going to add in a little extra step too. So a plane, let's go back to blue here. So a plane you are in descends at a rate of 20 meters per second, and you start at 10,000 meters. Okay, so my starting point is going to be 10,000 meters. Okay. I should be writing an equation here. And then my rate of change, right? My rate is 10 meters per second, or 20 meters per second. So this is going to be 20 meters per second. So I'm calculating here, and once again I'm calculating my height or altitude. I'll use height. Okay. So what's my height going to equal? Well, it's going to equal, so I'm going to go, h is my height, and my rate of change, okay, is in seconds. So I'm going to write that as seconds. Right. So my equation is going to be, well, my height is 10,000. Whoa, I just remembered this. I'm descending. That means my height's going to be going down. So I'm going to go minus 20s. So I'm going down 20 meters per second. Okay? So here's a question using my equation. After 29 seconds, how high am I flying? Okay. So my equation is this. H equals 10,000 minus 20s. And this here is my seconds. So I'm going to replace the S with 29. So I write this out again. H equals 10,000 minus 20 bracket 29, which equals 10,000 minus, and that calculation is going to be 580. This is going to be a long descent. 580, which equals 9,420 feet. 9,420 meters. So after 29 seconds, I'm at 9,420 meters. Okay? So I plug that in, I realized it was seconds, I plug that in for the seconds part. So the next one here, and I want you to pause it after I read it, so you can do, you can try it out yourself. So the value of your phone goes down at $5 per week. I did not change my color, right? So $5 per week, okay? That should have been gold. Underline that gold, so we do that in gold. I'll lose my pen every so often. And then, see if I have initial value. You buy the phone for $600, so my initial value is $600, right? Let's write an equation for the value of the phone. So V is going to be value, and then my other one is going to be W for weeks. And if we write the equation, we're going to get our value equals 600 minus 5W. Okay? So 600 minus 5W. So $5 per week. And our extra question here is, after how many weeks will your phone be worth $0? So we have to recognize that this here is the V value. So it's going to be worth 0. So your V is going to be equal to 0. And we're looking for weeks. That's our question mark. Beautiful question mark. So let's write down our original equation. 600 minus 5W. Then we're going to type in what we know, or put in what we know. So 0 equals 600 minus 5W. So now we have to solve for this. So let's move that over the other side, where it's going to become a negative 600 equals negative 5w. Now we have to get rid of this, so let's move it over, and it's going to become a divide. That should be 1200. Let's see here. 120 weeks. 120, yep. So 120 equals W. So if we were to do this properly, we'd write a concluding sentence here too, which would say, after 120 weeks, the phone would have no value. How does that just mess everything up with that? Okay. And make that small. There we go. Now we'll mess everything up. Good. Even though I still did. Hit enter here. Good. Now our last question here is, your car uses, this is a tough one. Your car uses 9 liters per 100 kilometers of gas, and you start with 50 liters of gas in your tank. That's a really awkward thing to use. Yeah. So, let's identify what we have. You can pause it here if you want to take a shot at it. So, where's my draw? Where's my initial? So we have our initial value or starting point here. The per, that's going to be rate of change. But our initial here is 50 liters. Right? So our initial is 50. Now what's our rate of change? 9 per 100 kilometers. It's kind of a messy one. So 9 per 100, so we could write that as a fraction. 9 over 100, right? So that is liters per kilometers. So we know one of these is always our second one. So we're going to go K equals kilometers. And this one here is a little confusing. Not confusing, but different. We're going to figure out how much gas we have left. So let's go big G for gas left. Okay? So our equation then is going to be G equals 50. Now we're using it, so it's going to be minus 9 over 100 K. So how much gas do you have left after traveling 444 kilometers? Now this is going to be our K value, right here. And we're looking for our G value. See if I need a better question mark. Oh, not bad. So let's write down our formula again. G equals 50 minus 9 over 400 K. Let's plug in our value. G equals 50 minus 9 over 400. Oh, sorry, that should be 100. Where's my eraser? Oh, Jebediah. There we go. No, that's really confusing. My eraser's writing. Times 444. Alright. So here I don't mind if you go 9 divided by 100 times 444. So G is going to equal 50. My thing slows down for some reason. Glitching out on me. Put her back to normal. Good. So 9 divided by 100 times 444, 39.96. So, oops, I got to erase again. Minus 39.96, which is going to equal 10.04. 10.04, right? So we have 10 liters left of gas. So there's a quick rundown about how to write an equation from a word description. Okay, so you're kind of looking for initial value. You're looking for a rate of change. I'll give you better instructions here. I just realized this sheet I didn't write out what the best equation was and what kind of equation I wanted you to write. So on your homework, I'll have it clearly written. The other part of this is today's lesson is direct and partial variation. Okay, and I'm going to touch on this, and we're going to link it back to the other one here. So let's go back here. Let's just draw a graph first. We're going to draw a graph of a direct variation. Okay, and it doesn't really matter what it is here. Here's my x and y axis, right? A direct variation is one that starts right in the origin and goes up. Okay, it could go any way you want. Actually, let me do this first. Goes right through the origin. Let me get a different color here too. It can go down as well, right? It can go any way you want. It could go, let's go green. Let's do an insert a line here. Oh, where's shapes? Right? So it could be any, well, that's not a line like I wanted, right? But essentially, it could go anywhere. Let's just draw. I'm not going to get all fancy, right? It can go anywhere, be any type of angle, as long as it goes through the origin right there. Okay? So let's go through here. Let's graph these two. Okay? So let's run this equation here. Where's my pen? Let's do this in, well, it's taking me so long to pick, and all you guys want this one, but I'm not going to, let's do this one for fun. Okay, so I made a table of values here, 0, 1, 2, 3. So what happens there is we're going to make W, since that's weeks, we're going to make W equal to 0. So if I were to write this equation, W equals 0, I go S equals 200 plus 15 times 0, right? 15 times 0 is 0, so we're going to be at 200 here. So my savings is going to be 200. Then I do it again, this time with 1, right? The notation here is 1 like so. I go 200 plus 15 times 1 equals 200 plus 15, which equals 215. 215. Then I repeat again. So we're going to go for 2 now. Equals 200 plus 15 times 2. That equals 200 plus 30. I'm never writing this pen again. And we get 230. If you look at your pattern, next one's going to be 240. So if I were to draw this graph, weeks are going to be down here, because this is our X value and this is our Y value, okay? And then savings are going to be here. Let's say this is 200. I'm just making a rough graph. 200. We're going to start here. Let me change my pen, right? So we would start here and we go up. So 1 week, we go up $15. 215. and we go up, kind of like this. Now I know my graph isn't perfect, but we kind of get the idea there. So by this estimation, is this a direct one? Or, as I realized I never did a partial, let's do a partial variation. A partial variation, and I'm drawing this because it could just be the top, but anything there. A partial variation is a graph that does not go through the origin. So I can make this line, that would be a partial. I can make this line, that's not a partial, because we're not going through this spot right there. Okay? I can make anything I want as long as I do not go through the origin. I could even make a horizontal line if I wanted to. That just went straight across. No origin. Okay? That's right here. Does not go through the origin. Okay? And the one here goes through the origin. So with that in mind, what is this one? Is this partial or is this partial or direct? Well, it is partial because it does not go through the origin. Okay. And let's run these numbers. So we have a table of values, so let's hit the numbers here. So h equals 10 times 0, h equals 0. Then we're going to do h1. So after 1 second, how high are we? Right? So we go 10 bracket 1. Well, it's 10. This one's 10. Then we're going to go h at 2, which equals 10 bracket 2, which equals 20. So here's going to be 20, and then h equals 3, 10 times 3, which equals 30. Now, we can graph this. Where do we start? We start at 0, 0. This is going to be our first dot. Let's change color so we can see it. Let's go green. So our first dot's going to be here. Then our first one at 1 second. It's going to be at 10, 2 seconds. We're going to be at 20. It's going to look something like this as our plane takes off. This one here goes through the origin, so it is direct because it goes directly through. Now, knowing that, let's see, it's two equations. So looking here and here, where's my pen gone? Looking at this and at this, what can you tell me that the partial variation has in their equation that the direct variation does not? I'll give you a little bit to figure that out. So what does the partial have that the direct does not? Now, if you said the partial has an initial value, initial cost, or a starting point, you're right. Okay? Let's scroll down like this, and this would be in your notes of future self. A direct variation, the formula, has no starting / initial, right? Starting point. So the equation is going to look something like this. If I just use this, y equals 10x. Nothing after it. Okay? Where this one here has a start, has a initial. Oh man, I killed that word. initial slash starting point. So it'll have, if I do the same thing, y equals 10x plus or minus a value. So an example would be y equals 10x plus 3, or the cost equals like 3p plus 10, right? Let's say the value equals 500 minus 2v, right? The 500 is the initial. If I want to do something here, cost equals like 10 times p, or the value equals like 30 times weeks, something like that. These have no initial, so it's just that, okay? So that's today's lesson. I know that went a little bit long, but hopefully you understand it. And on